Hi, we will ask the ChatGPT. It is homework 8. Can you give me a basic practice question on BFC? Okay. BFC. Thank you. I'm solved this question. Let's start by implementation the breadth first search BFC algorithm to find the connected components in undergrad graph. Yes, the BFC connected components function takes an undirected graph as input and returns a list of connected components using breadth first search BFC. Here's a step-by-step explanation. It is visited set. A set keep a track of visited nodes and components. A list store to connected components. Let me see. That's right. And define BFC function. BFC start this function performs BFC starting from the given node start. Initialize an empty list component to store the nodes in current component. Use a delegate queue to perform BFC. Yes. And the start node, the queue and mark it visited. While the queue is not empty, pop a node from the left of the queue, add the node to current component for each neighbors of the node. And iterate through all nodes in the graph. If a node has not been visited, call the BFC function starting for that node. Add the resulting component to component list. And return the list of the connected component. This is the example usage. Yes, example usage, the graph. Create a sample graph and call the BFC connected components with the graph and print the result. This implementation uses BFC to traverse the graph and identify connected component. Connected components are groups of nodes that are connected to each other but not the nodes outside the graph. The time complexity of algorithm is O V plus E. And I'm asking time complexity. Yes, and my internet is not so. Okay. Where V is the number of vertices, nodes, and E is the number edge in the graph. Space complexity is O V for the visited set and component list. And I'm connected to the internet. Yes, I'm solving this problem. Below is a detailed explanation of breadth first BFC algorithm for finding connected components in undergraded graph. along with its implementation in Python. Breadth first search is a graph traversal algorithm that explores the vertices of a graph level by level. It starts from a given source vertex and visits its neighbor before moving on to the next level neighbors. In the connected of connected components, BFC can be employed to identify groups of nodes that are interconnected. In our Python implementation, the graph is represented using agency list. This representation involves a dictionary where each key value pair corresponds a node and it lists neighbor nodes. This is for example. This representation indicates that node 0 is connected to nodes 1 and 2 and vice versa. A set is used to keep track of visited nodes during the BFC traversal. This prevents revisiting nodes and infinite loop. This list stores the connected component found during a traversal. Each component represents as a list of nodes. A function is defined to perform BFC starting from a given node. It utilizes the double-ended queue to efficiently pop and append nodes. A function is defined to perform BFC starting from a given node. The BFC algorithm can be outlined as follows. Initialize an empty set visited and empty list components. Define a function BFC start to perform BFC from a given starting node. Iterate through all nodes in the graph if the node has not been visited. Call BFC to explore the connected component starting from the node. Add a resulting component to components list. The BFC function is critical for the BFC traversal. It takes a starting node and returns a list representing the containing component. Initialize an empty list component to stop the nodes in current component. Use a dequeue, queue, the enqueue, and dequeue nodes. The BFC function if the neighbor has not been visited, mark it as visited and enqueue it. Return the component list. The time complexity of the algorithm OWB, again, I say it. And I'm running this code. Yes, I'm waiting. And starting. Okay, yes. This is the scene. New scene. 0 by 2 and implementation. And 3, 4. Okay. It is correct. Thank you. Thank you. Okay. This then is y. Okay, fantastic. BFC algorithm and sorry. It is the first search, press first search. The first search and first search different. Yes, the first search. First search and first search are both algorithms used for traversing or searching through the graph and trees. But they differ in the approach to exploring the nodes. Here are key difference between DFC. DFC explores possible along neighbors. Yes, it is differences possible along and neighbors along. Yes. DFC example. Yes, example graph. Yes. This is the output capacity. And you draw the graph. Yes. It seems like node A is connected with B and C, and B, E, A, B, C. Yes, it is. I am choosing the response one. Okay. Yes, we look the BFC algorithm example. Yes, it is there. So you know when you have this hug web of connected points or nodes, and you want to find the shortest path from one point to another, that's where the breadth first search algorithm comes into play, and let me break it down for you. Alright, imagine you're standing at the starting point and you want to explore the nearby spots first before moving on the farthest ones. That's the essence of BFC. Here's how it goes step by step. You kick off from your initial spot, marking it as visited because, well, you are standing on it. Now, instead of randomly jumping around, you decide to visit all the immediate neighbors of your current spot. You tag them as visited and make a mental note to check out their neighbors next. After you have said hi to all your neighbors, yes, these neighbors, and yes, these neighbors. It's time to move on. You dequeue yourself from the current spot and jump to next one dequeue. And queues what? You repeat the process with neighbors, mark them as visited, and keep track of their neighbors. Yes. This keeps going on and on until you have visited all the spots or nodes in the network. You are basically spreading out in all directions, exploring step by step. The cool part. BFC grants that you find the short path because you are not leaping ahead. You are metaphorically going level by level. Oh, by the way, I almost forgot. To keep the things organized, you use this thing called a queue. It is like line at a grocery store. The first one in, the first one out. So you enqueue the nodes you are planning to visit. Neat, huh? And that's BFC for you. It's like exploring a city. You start where you are, visit nearby places first, then move on, while keeping things systematic. Whether it's finding the correct router or checking if two plus are connected. BFC is your go-to algorithm for navigation nodes. And so think of it like this. BFC is our method of storing through the data. You know, We are trying to find the shortest path from one point to another. But hey, gotta take it step by step. Imagine someone getting lost in city using BFC. First, they explore the immediate neighborhood, then move on to next one. It's like saying hi to neighbors before venturing farther. Picture a BFC. Yes, you know the BFC algorithm. Target node vertex. Picture BFC as methodically checking the branches of a tree. You started at the top node, divide into one branch, explore its nodes, then hop to next branch. It is all about methodically uncovering layers. BFC, like navigation and maze, systematically moving through each corridor before considering the next. It's not about the random jumps. It's a careful, level-by-level exploration. And this algorithm is your GPS for finding the shortest route. It is not about the field lips. It's about navigation through layers, like peeling an onion. Each layer reveals a bit more until you reach the core. Think of it's exploring a city discrete by discrete. First, you check out one area, then move on to the next. BFC, you're quiet, ensuring you don't miss the shortest path or any hiding gems along the way. Yes, it is the great first search algorithm. And okay, thanks. It is finished. It's finished. Thank you. And bye bye. Next one, the homework. I see it. Bye bye.